Alright folks, here we have a traditional stoichiometry problem. So this is one that a lot of us are still a little concerned about, and I know it is difficult. So let's look at one. According to the following reaction, how many grams of hydrofluoric acid will be formed upon the complete reaction of 24.1 grams of water with excess silicon tetrafluoride? So we have a couple things here given to us from the beginning. Number one, it's telling us what we're looking for. In this case, if we read the question, according to the following reaction, how many grams? So that's the first thing that we need to take note of. We are looking for grams of hydrofluoric acid. So that is the compound that we want to focus on. Will be formed upon the complete reaction of 24.1 grams of water. So that 24.1 grams is describing water with excess silicon tetrafluoride. Now, if we look at our chemical equation here, we have silicon tetrafluoride plus water as our reactants, and hydrofluoric acid plus silicon dioxide as our products. Now, our equation is not written out in a complete balanced equation. It's written in words, so that's something that we need to take care of. So if we're looking at our chemical equation, we have silicon tetrafluoride. So silicon tetrafluoride, like we did in the last one, naming the things in our equations. Silicon has the chemical equation, or the chemical formula, Si. Tetrafluoride tells us that we have 4 fluorines. That is going to be added to water, H2O, which is going to make hydrofluoric acid. Now, in the last one we talked about acids briefly. When we're forming the names of acids, most of the time they are going to start with an H. In this case, hydrofluoric acid is simply one hydrogen paired with one fluorine, because fluorine has an oxidation number of -1, whereas hydrogen has a +1. So you just need one of each. Plus silicon dioxide, which is going to give us the formula SiO2. All right, that's our chemical equation. Now, it's not balanced, as you can see, so we're going to need to balance it. So on the left side, I have silicon, fluorine, hydrogen, and oxygen, and I have the same elements present on the right side. So I'm going to make those lists on both sides so that I can compare the numbers of atoms. On the left side, I have 1 silicon, I have 4 fluorines, I have 2 hydrogen, and 1 oxygen. On the right side, I have 1 silicon, 1 fluorine, 1 hydrogen, and 2 oxygens. Okay, so again, we're going to start with whichever one is usually easier to solve and to fix. So in this case, if we look at fluorine, fluorine is only present in one of our compounds on either side, and we have a discrepancy here between the two. So I have 1 on the right, 4 on the left. How can I fix that? I need to quadruple my number of fluorines on the right side of my equation, so that will give me 4 fluorines. That 4 is also going to multiply our hydrogen, giving us 4 hydrogens. Okay, so that solves our fluorine problem. Our silicon problem is already solved. Our hydrogens now have a problem, as well as our oxygens. Now, one thing you'll notice is between hydrogen here, this hydrogen is double this hydrogen. This oxygen is double this oxygen. So because both of those two elements are present in our water right here, we can simply double our water, giving us 4 hydrogens and 2 oxygens. There we go. Now our lists match one another on the left and the right side. Okay? So that's the first step in figuring out this general stoichiometry equation. Now, we need to look at how much stuff do we have and what are we going to do with that stuff. So looking back at the question, remember we're looking for grams of hydrofluoric acid is going to be formed upon the complete reaction of 24.1 grams of water with excess silicon tetrafluoride. Now hopefully you remember when we see that word excess, we're going to X it out because that is more than we need. It is not going to affect our reaction. So let's go ahead and list out the information that we know. I'll keep that there for 1 second. So we know that the mass of our reactant is 24.1 grams of water. Okay, that's one thing that we know. We also know that we are looking for grams of hydrofluoric acid. So I'm going to put that down here as what I am looking for. Question mark, grams of hydrofluoric acid. Now, I need to know what's going to get me from point A to point B. Okay, and this is the general stoichiometry equation where we can follow the same train tracks every time when we're going from grams of one substance to grams of another substance. And so that means there are 3 steps that we're going to need. We're first going to need the molar mass of compound A, which is 18.02 grams per mole of water. That's the molar mass of compound A. Then we're going to need the mole ratio between the compound we start with and the compound we are ending with. So we're starting with water, we're ending with hydrofluoric acid. That means we're going to look at our chemical equation to find what the mole ratio is. So if we look at our water and hydrofluoric acid, we have 2 moles of water as a reactant and 4 moles of hydrofluoric acid as a product. So the mole ratio will be 2 moles of water for every 4 moles of hydrofluoric acid. Okay, that's step 2. Now step 3, we're going to need the molar mass of our ending compound, what product we're trying to get to. So the molar mass in this case of hydrofluoric acid, which is 20.01 grams per mole. And you'll recall that the molar masses right here we get from the periodic table. So those are going to be the things that are going to help me get from point A, mass of water, to point B, mass of hydrofluoric acid. All right? So now I'm going to move my problem up. So once you know all the things that you're going to need, remember for me, I use the train tracks. If you want to use a different process, that's fine. We start with our initial mass of water, which was 24.1 grams of H2O. Okay, so I'm going to begin with that in my train tracks and go ahead and draw that out so that I know where I am going. And when I know where I'm going, I should also fill that in so that I end up with that. Okay, so in the end, I want to end up with grams of hydrofluoric acid as a result. Okay, so I want to get rid of my unit of grams of water, and so the only way that I can do that is by converting my water to moles. Because if I convert grams of water to moles of water, then I can convert moles of water to moles of hydrofluoric acid. And then I can convert moles of hydrofluoric acid to grams of hydrofluoric acid. All right? So I'm going to take my molar mass, and I'm going to use that next. Now I want to follow my units, so if I start with grams on top, I need to put grams of water on the bottom so that they cancel each other out. And we're converting that to moles of water. If I use my numbers and follow my units, I remember that 18.02 grams is equal to 1 mole of water. So that will cancel out our unit of grams. Now I'm ready for the next section of my train tracks where I want to get rid of the unit of moles of water. Okay, so the thing that I need to use to do that is moles of water versus moles of hydrofluoric acid. So if I look at my mole ratio, I have 2 moles of water for every 4 moles of hydrofluoric acid. Okay, that's going to cancel out my units of moles of water. Okay, now I want to get rid of my moles of hydrofluoric acid. The only way that I can convert from moles of hydrofluoric acid to grams of hydrofluoric acid is the molar mass of hydrofluoric acid. So that's going to be the last thing that I'm going to utilize to get to my answer. So I bring my moles of hydrofluoric acid down here, moles HF, and that 1 mole of hydrofluoric acid is equal to 20.01 grams of hydrofluoric acid. All right, that is going to cancel out my unit of moles of hydrofluoric acid, which leaves me only with grams of hydrofluoric acid left as a unit. All the other ones have been canceled out, which is what I want. So in order to figure out what all that equals, I need to multiply 24.1 times 1 times 4 times 20.01 divided by 18.02 and divided by 2. If I complete those calculations, then I end up with a total of 53.5 grams of hydrofluoric acid. And that is our total grams of hydrofluoric acid, which if we look up here is exactly what our question was looking for. So I can fill in 53.5 grams of hydrofluoric acid. And one last note that I want to point out is if you'll notice, my answer has 3 significant figures in it, which matches the 3 significant figures of the information I was given in the question. That is essential for these questions.